All right, I got a quick question, but one that represents pretty much the sum of what we've talked about this entire experience. So let's go ahead and read what we have. So figure 2.35 summarizes the law of electrostatics in a triangle diagram relating the source, ρ, the field E, and the potential V. Figure 5.48 does the same for magnetostatics, where we have source J, field B, and potential A. So, let's go ahead and construct the analogous diagram for electrodynamics, with source ρ and J, constrained by continuity equation, fields E and B, and potentials V and A, constrained by the Lorentz gauge condition, and do not include the formulas for V and A in terms of E and B, because, well, we're not going to want to go backwards to find the potentials. We want the potentials to find the fields. All right. So that being said, we got quite a bit to deal with. So at the top, we have our sources, again, constrained by the continuity equation. We like that. The potentials, V and A, again, constrained by the Lorentz condition, which is divergence A is equal to negative 1 over c squared dV dt. And then the fields, which for this particular setup, we have the divergence of B equals 0 and the curl of E equal the negative dV dt. So we like everything we see here. And yeah, I'm going to let you go ahead and read everything. We already discussed this in full length with several of how these things got started. Yeah, the other thing to notice here is that we have to evaluate certain things at the retarded time, and those are the ones in the bracket. I'll just post a picture. You can look at it for yourself, or you can pause the video here, but here you go. Thank the author for this one, because that is a lot to deal with. But that's pretty cool how we can summarize this whole thing. Wow, I like it.